Thank you so much, Thomas, for the very good introduction. You made it very easy for me to introduce this topic. I'm going to talk about air pollution in the United States. And I have this framework for remembering what it was, understanding what it is now, and anticipating what it can be in the future. First things first, the US Environmental Protection Agency started in 1970, and they funded artists to go out and take photographs of the environment where they lived. And Chester Higgins was a photographer who lived near where I grew up. And so he took this picture of the George Washington Bridge in 1973. And I can't believe it. But when I first showed this photo to my mom, she was shocked that I was shocked. She said all the bridges in New York City looked like this in the 1970s. And this is a more recent picture of the George Washington Bridge from Wikipedia, and you can tell the air quality is dramatically improved. I grew up on the East Coast of the US, and I moved to California sort of recently. I'm still working to develop a West Coast perspective on air quality. And so I go hunting and for images like this, and this is one of my favorites. This is from 1954, 16 years before there was a US Environmental Protection Agency. This is an image of a building in Los Angeles taken from about the same distance. And we can see that air quality today is a lot better than it was. And people no longer have to drive around with gas masks on. One city, or first, the emissions that adversely affect air quality are the same emissions that impact climate or cause the climate emergency. And so, one of the things that happened while I was in the White House was Climate Week in New York City. Right here in this photograph is John Kerry. He's a presidential special envoy for climate. So they had Climate Week, and then right as that was ending, New York was hit with a 1 in 1,000 year storm. This is the subway station that you would take to get to Climate Week, and here's the train coming, and the infrastructure there is pretty unusable. And so when we want to affect change, and we want to affect change rapidly, I went searching through the air quality history to see what I could find as the best example. And so I think for me, it's Birmingham, Alabama. In 1971, there was this heat wave stagnation event, and air quality had gotten very, very poor, and hospital admission rates and deaths started to rapidly increase. And at the time, before EPA was created, local health departments, so states and city health departments would be in charge of air quality. But in 1970, EPA was created. And so in 1971, when this stagnation event happened, just like the one in London that caused 4,000 deaths, the local health department in Birmingham reached out to EPA and asked for help. And so this is like the very first time EPA is really being tested. And the Clean Air Act has an emergency powers provision. And so EPA sent their attorneys to Birmingham. They got this emergency injunction. They shut down cement kilns. They shut down electric generating units. And people can quantify how many people didn't die during that stagnation event. And now air quality in Birmingham looks something like this. And I think it's no mistake that the very first use of the emergency powers provision took place in Birmingham, the city where Martin Luther King had had his march just a few years earlier. And so it's these areas that are ripe and eager for social change that caused rapid improvement in air quality for their localities. So, US air pollution is regulated a little bit differently in the US compared to the EU. I don't know how our states compare cooperation wise compared to the EU member states. But in the US, the Clean Air Act, the very first one was in 1963, and that was the act that empowered local health authorities and local health departments. In 1965, there was a Motor Vehicle Air Pollution Control Act. In 1967, there was the Air Quality Act. And then when people talk about the Clean Air Act, they're typically talking about the Clean Air Act of 1970. And so when Republican President Richard Nixon created the Environmental Protection Agency, he asked Congress to pass a law that would empower this new federal agency. And so they passed the 1970 Clean Air Act. The Clean Air Act was amended in 1977, and then the Clean Air Act was amended again in 1990. One thing that's really interesting is now in the US, issues like air quality can be sort of partisan, but in 1990, they were not. Mitch McConnell voted in support of the Clean Air Act amendments. He said, "This will protect my constituents. It's an absolute no brainer." But the Democratic senator from Ohio was John Glenn, American astronaut John Glenn, and he was a Democrat and he voted against the Clean Air Act amendments. So there didn't used to be this partisan divide on environmental issues like there is now. And then finally, with the Inflation Reduction Act in 2023, Congress said that carbon dioxide is a Clean Air Act pollutant. So the US EPA then promulgates standards that define what compliance with the Clean Air Act or with the Clean Air Act amendment means. Typically and traditionally, these were command and control rules, or more recently, we call them performance standards, and they target large individual point sources. There can be cap and trade programs, and I'll talk about that in the context of acid rain in a little bit. And now, I would say the approach that gets the most attention in the US is a airshed approach, and we have these criteria air pollutants, and that's just like what the PM 2.5 discussion in terms of Europe was like. So I showed you some compelling photographs, but we can't use snapshots in time to robustly evaluate trends. So for the criteria pollutants, and they're listed here, carbon monoxide, lead, sulfur dioxide, nitrogen dioxide, ozone, and particulate matter, EPA has surface monitors all across the US, and each pollutant actually has a very strict operational definition, and I'll talk about that in just a moment in detail for particles. But then what they do is they take the measurements from these surface monitors, and then we come up with trends, where this would be the x-axis and this would be the y-axis, and then EPA evaluates whether or not an area is attaining a national ambient air quality standards, or a NAAQS. So in February 2024, so something that happened in between when we were scheduled to meet in October and today, is the EPA passed a new, or promulgated a new PM 2.5 national ambient air quality standards of 9 micrograms per cubic meter. So we're lagging behind Europe a little bit. You have a tighter standard. So the first 4 criteria pollutants are directly emitted to the atmosphere, but the last 2 pollutants, ground level ozone and particulate matter, actually form in the atmosphere from precursors. And under this airshed or criteria pollutant approach, the individual states in the US actually have a lot of autonomy. They have to meet airshed values. When they're in non-attainment, states prepare state implementation plans that demonstrate how they will attain the standard. So that we have air quality models, just like Europe has, and then states will go in and say, "This is our plan to meet the standard," and then they do different model simulations to demonstrate that their air quality will improve. Can people still see me?
Yes.
Okay, sorry, it's just really early, so the light just won't stay on. So for PM 2.5, the national network was implemented in 1999. And so I'm showing them decrease in mass concentration averaged across the US. And at the time, at the EPA website, they still have 12 listed as the national standard, even though now it's 9. But here's the thing. Um, I'm looking at, on this map, each individual point represents a monitoring location for PM 2.5 that was continuous over the time period listed on this slide. If a monitoring location is indicated by a black square, that means the improvement in PM 2.5 mass concentrations is within the interquartile range of the national average. If a monitoring location is denoted by a green triangle, that means the improvement in PM 2.5 mass outpaces the national average. And if a monitoring location is indicated by a blue diamond, that means the improvement in air quality lags behind the national average. And so when EPA shows us this 42% national improvement in air quality, it's very heavily weighted by where the monitors are. There's a lot of monitors in the eastern part of the country. There's actually a lack of monitors here in the middle of the US, and I want you to remember this arc right here for later. But that 42% increase is largely driven by these monitors east of the Mississippi River and a handful of monitoring locations in Los Angeles. The national improvement in air quality for PM 2.5 in the majority of the land area actually is much less than 42%. And I wonder how that looks in Europe. I don't really know. And so that improvement in PM 2.5 is actually an ancillary co-benefit of rules aimed to reduce sulfur dioxide emissions. And these rules were implemented to deal with acid rain. And so here what I'm showing on the left-hand side is acidic deposition from 2000 to 2002. And on the right-hand side, I'm showing acidic deposition more recently. The hotter the color, the more acidic the deposition. And we can see that there's been this dramatic decrease. And that comes from a reduction in SO2 emissions, which caused a reduction in PM 2.5. And I'll get into that in just a minute. So EPA's air pollution policy has had tremendous success reducing emissions from large point sources, from toxic emissions in highly populated areas, and from motor vehicles. The land sector, which is most of the land area in the US, has been traditionally more difficult for EPA. And I showed you how there was that swath across the Midwest of the US where there were no monitors. And so a question that we've been wondering about is how accurately do regulatory networks describe the atmospheric burden of particulate matter pollution? So I had mentioned before that most particulate matter forms in the atmosphere. And so what happens typically is you form a salt. You have an acid plus a base, and then you form a salt. So two primary components of PM 2.5 are ammonium sulfate and ammonium nitrate. And so you get ammonia, which primarily comes from livestock, interacting with oxidation products of sulfur dioxide, and then you make ammonium sulfate. Or you get ammonia reacting with oxidation products in the nitrogen cycle, and then you make ammonium nitrate. EPA regulates SO2 through its acid rain program, and EPA regulates NOx through its ozone program, but ammonia emissions are not regulated. And so here I drew this map for you, and because you're from Europe, I used European Space Agency's IASI instrument on board their satellites, and this is over the contiguous US. The deeper the blue color, the more ammonia there is. And this swath where ammonia is actually coincides with where EPA has no monitors. This part right here, this is California's Central Valley. This would be considered America's bread basket. This would be considered America's fruit and vegetable basket. And overlaid on that ammonia map, I have the five most polluted cities for year-round PM 2.5 in the United States. And perhaps you notice a pattern. They're all in California. The most polluted cities for year-round PM 2.5 are all in California. And the Central Valley, where we have a lot of ammonia, is actually the top three most polluted cities. And so I wanted to understand what might be going on. And so I went to the US Department of Agriculture's Census of Agriculture, and I looked up how they describe animal units. And I'm not going to go into too much detail today. This is just an overview talk, but if you want to catch up afterwards, I would happily talk your ear off about it. But the USDA reports animal numbers by county, except when an agricultural enterprise is so big that it would enable you to know exactly who it was, then those numbers, those animal numbers, don't get reported. And so we worked with a non-governmental organization to figure out where the missing animals were. So USDA also keeps track of animal numbers at a state level, and those numbers are based on tax receipts, and so they keep a little bit better care. So the animals that were missing in between the state total and what we could derive from summing up the counties we assigned those animals to the counties that were missing from the Census of Agriculture. And we also used Google Earth to look and make sure that there were agricultural enterprises. So here again, I'm showing the annual or the summertime average in ammonia from the European Space Agency over the US. And here I'm showing animal unit density. So we normalized by weight across the US. And perhaps you can see this arc across the Midwest. And so I gave those animal unit numbers to a colleague who is a statistician, and he drew us this level set. This black line outlines the area of the US that has the 91st percentile and higher of animal units in the US. It looks, you overlay that on the ammonia map, and they look pretty similar. One of the things I actually like is you can tell prevailing winds are to the east, and so you see ammonia bleeding out of that animal set because ammonia blows more easily than cattle and hogs do. And then here what I'm showing are EPA monitors that are within the level set. These are all of the monitors EPA has in that area. 3 are characterized as rural, more are characterized as suburban, and then these 2 purple ones are characterized as urban. So where we have these highest concentration of ammonia, there are no monitors, there are no surface monitors. And one of the things I think that's troubling about that is European Space Agency instruments and NASA instruments show that ammonia concentrations are rising over the US. That is in sharp contrast to most other controllable pollutants, and EPA is not monitoring in those locations. I said before that all measurements are operationally defined, and EPA has very strict definitions for what a PM 2.5 monitor is, and they specify what kind of filter you have to use. And so when I showed you the improvement in PM 2.5, in the eastern part of the US, most of that particulate matter, or a lot of that particulate matter, is ammonium sulfate, which is non-volatile and is well described by central monitors. But in the Midwest and in the western part of the US, ammonium nitrate is a dominant constituent of fine particle mass. And the type of filter that EPA uses in the PM 2.5 monitor is very well documented for not recording ammonium nitrate well. So here, what I'm showing is the trend in PM 2.5 mass for those 3 most polluted cities in the Central Valley. This dark blue line is the reported PM 2.5 mass in the regulatory database, and the shaded blue part is the PM 2.5 after we account for ammonium nitrate losses from the filter. And so we just passed this new standard of 9 micrograms per cubic meter, and none of those cities have any chance of meeting that standard anytime soon. And the air quality burden is actually much worse than what's recorded. A positive note, perhaps, though, is that the amount of nitrate that you lose is a function of how much nitrate you have. So when I first moved to California, this trend in PM 2.5 mass for Kern County was one of the first plots that I drew. And when I look at the slope of that line, there is no slope. Air quality from a PM 2.5 perspective has not improved at all. And that broke my heart a little bit. But when we account for the nitrate loss, it does seem like there is a negative trend in PM 2.5. And so it maybe is improving. It's still unacceptable. And it's underreported in regulatory networks. There's a lot of policy regulation hurdles for agriculture in the US. EPA regulates ammonia under 2 different rules as a hazardous substance and an extremely hazardous substance, except when that ammonia is present on a farm. EPA entered into a final order with concentrated animal feeding operations in 2006. And if they contributed to an emissions study, then they would be covered and protected from all criminal and civil liabilities. And then EPA would finish this emissions model, and then action could take place after that. But that happened in 2006. My students would tell you that that was a long time ago, and it's still not. The emissions model is still not finished, and that order protecting animal husbandry operations in the U.S. is still in effect. I don't want to get too stuck in the weeds on this, but again, if anyone wants to talk about this offline, I would very happily talk your ear off about it. But just know that there are specific rules like the Farm Act, and there are specific riders in large omnibus bills like the Appropriations Act that prohibit the use of funds by state agencies to adequately, in my opinion, adequately address air pollution from agriculture. And so agriculture is the largest source of several air pollutants that degrade air quality and contribute to the climate crisis. But ag emissions are poorly quantified. And it's my opinion that the hurdles to this are largely social and political. They're not scientific or technological, just like that heat wave stagnation event in Birmingham. And so when I think about climate and going forward, the largest source of methane in the US is agriculture, and agriculture is largely exempt from all um, emission rules and international agreements. I'm sorry, the staff is in my office scheduled cleaning it. And so the largest source is enteric fermentation plus manure management, and it is exempt from methane rules. And when I look at the fractional contribution to total greenhouse gas emissions across the US, the fraction that is coming from agriculture is rising over time, and it's rising for two reasons. One is emissions from the ag sector are increasing. And then second, all other source categories are being regulated, um, and their emissions are decreasing. So summary, and I tried to think of questions that might be good for discussion. The emissions that adversely impact air quality also impact climate. And so I think there are some lessons learned, and it would behoove us to think about that. In the US, at least, rural air quality is not as routinely measured relative to urban population centers. And to what extent does this hinder accurate quantitative understanding of current conditions and trends? And I think one of the things that's really exciting is I love IASI. I love NASA. 21st century science and technology makes it harder and harder for pollution to hide. And so what role should new tech play in regulatory policy? In the US, it almost doesn't matter if a satellite is telling me pollution is increasing unless a regulatory monitor has told me that very thing. It's hard to affect change. I want to thank Concawe for inviting me and including me. I'm really sorry about the interruption to my office. I don't have control. Um, I really have benefited greatly from federal agencies that have funded my work: NASA, NSF, the National Science Foundation, NOAA, EPA, the Department of Defense, and the White House. And the other thing I want to say is that the maps and plots that I made for you at the federal level and the state level and the local level, there's technicians that take care of these instruments and build the satellites and program managers that make funding decisions. And I did none of this work by myself. And Alyssa Burns, Gabe Chandler, Kara Dunham helped me with this. And thank you so much for your kind attention.